Okay, moving on to problem 2. This is a fairly straightforward problem in calculating input and output impedance given sufficient information. The easiest way to start this problem is to simply draw an equivalent circuit. I always draw an equivalent circuit because it helps my brain get around the problem. If you try to do everything in your head, you have a lot of problems, and so you draw pictures. It will make life easier. We start with a correct pen. And we draw a voltage source in series with some impedance I will call Z1. That is the output impedance of circuit 1. I'm going to attach that to circuit 2, which I'm representing by an input impedance called Z2. The voltage I am given is the voltage on the output when there's nothing connected. That's 10 volts. So that's basically the Thevenin equivalent voltage of circuit 1. The voltage when it is attached in circuit is 8.57. I will call that V prime when the thing is hooked up. Then I just need to use my voltage divider equation, which says that V prime is going to be equal to V out times the ratio of Z2 to Z1 plus Z2. So here's the equation. I just need to solve it for the unknown. Now I'm given this one, I'm given this one, and in this case I am given the input impedance of circuit 2. So I'm given Z2, and I need to find Z1. So I will then rearrange this equation and find Z1. So I have Z1 plus Z2 times V prime is equal to V out times Z2. And I want Z out 1. So I'm going to solve that. I'm going to have Z1 times V prime is equal to V naught times Z2 minus V prime times Z2, which I can write as Z2 times V naught minus V prime. And finally, Z1 is equal to Z2 times V naught minus V prime divided by V prime. So that's the equation. That essentially solves the problem. The rest is just plugging in the numbers, which you get as follows. Z1 is going to be equal to 600 ohms times the ratio of 10 volts minus 8.57 volts divided by 8.57 volts. And if you do this on your calculator, you wind up getting 100 ohms, which is this answer right there. And that's it.